This is Hongshuo Wang. I am the person who is in charge of object detection in self-driving project. First, I would like to say thank you, Professor Liang, for me this great opportunity. Moreover, thanks to my partner Kavan, Tommy, and Owen. Without their great jobs, our project could not be done successfully. Okay, let's talk about what I done in this project. Besides the other members, my job is a further extension of self-driving. Again, just repeat our project goal. It's transforming steering control to self-driving. We want to use the actual steering wheel controller to drive our J-bot in a mini town and perform specific tasks when encounter a traffic sight. For example, when you see a stop sign, your car must stop a while. Or for non-left turn sign, your car can only go straight forward or turn right, etc. However, when the J-bot sees multiple sides at the same time, the traditional classification module can only recognize one side instead of several sides. To overcome this problem, we need object detection. Object detection usually is a deep learning virtualization technology that takes image or video streams as an input to detect objects in desired domain and use bounding box to visualize it. Based on image classification, my job further implements object detections on 5 traffic sites: stop, intersection, non-left turn, parking, and one-way. Next, I'm going to talk about how I implement the object detection. Usually, I decide to use transfer learning instead of training on the raw model due to the consideration of time saving and limited computing power. What I list in the slides are the 5 main steps I implement module. First, collecting data in order to create a dataset for 5 traffic sites. Next, selecting suitable module. Then, training the mode. Then, evaluate the training mode on JSON Nano. Finally, improve our module. First, collecting data. Thanks my partner Kavan and Tommy again for helping me collecting the data. Since our program is using the default JSON Nano camera as the input, we decided to use JBot camera to take the pictures. We took about 200 images per class and about 1,000 in total image. Then, we use label-in program to label objects. This open source programs will output XML file which records the bounding box and class types information for the corresponding image. When I import my label image, both JPG file and XML file to RoboFlow program, which will take do the data augmentation and transfer your data into specific version, satisfies different module needs. I did rotation, cropping, and sharing on our input image, and finally enlarge our datasets to 2,355 images in order to get a more robust module. Next, I need to decide which kind of module I need to take. By doing research and looking at the official NVIDIA website, I picked 3 potential options: YOLO v3, SSE Mobile v2, and YOLO v4. All of them are current popular module on mobile object detection. It most took me 3 weeks to prepare the data, build the environment, train 3 modules, and fine-tune them. I was first thinking to train the module on the JBot, but when I test on the JBot, it runs extremely slow since the JBot got only 5 GB memory and limited GPU. In order to save time, I make most of Colabs by creating several Google accounts and train all the modules on a Colab at the same time. This time I list in the slide is the average time I took to train the module. Last, I want to combine my final 2 topics together. The biggest problem I faced as I train each module and evaluate on the JBot is running speed. Because of the JBot limited performance, as I mentioned before, the module runs unaffordable slow at low FPS. When I look at the official guides of the JSON Nano, it suggests to compile your transform trained models into an engine file. which speed up the performance of the module on JBoss. Depending on the GitHub module's tensor demos, I successfully built up the engine file and compared the results parameter. I made some trade-off between callbacks and FPS, and finally, I decided to pick YOLO v4 tiny module as my final module. You can see how well it performs in the module slide. Thank you for your watching.